So the Earth is said to be a sphere, although not a perfect sphere. It is proposed that it is actually a oblate spheroid. And if you go to Google Images and type in oblate spheroid Earth, on the very first page you'll come up with 4 diagrams or 4 pictures here that all give the same value for the oblateness of the Earth, and that is that the equatorial diameter is 12,756 kilometers and the polar diameter is 12,714 kilometers. So all of these pictures, this one, this one, this one, and this one, they all have the same distances. So I'm going to go ahead and assume that that is the accepted size of the Earth. So with that in mind, I decided to draw an exaggerated cross-section of an oblate spheroid, which is an ellipse, like this. So this is greatly exaggerated. The polar distance is much smaller than the equatorial distance here. So I went ahead and drew a 45-degree line from the centre to the surface. And at the surface I drew a 100-metre tall building by 20 metres wide, but I drew it perpendicular to the ground that it's actually on. So I drew a line from the intersection here, and I drew a straight line 20 metres along this curved line to here. So it's a straight line on top of a curved line, and then I drew perpendicular from that 100 metres upwards and created this building. I then drew a line from the top of the building, simulating somebody standing on the roof and holding a plumb bob from the top of the building, and observing which way the plumb bob would swing to pull itself to the centre of this exaggerated oblate spheroid Earth. And as you can see, we zoom out the blue line here and the purple line, they both intersect at the centre point. So that was just to illustrate what it would look like if it was exaggerated and the sort of dynamics we're talking about here. Now this same effect would occur all the way in each quadrant of this oblate spheroid. So until you actually got to the pole here, or the equator here, the angle of the plumb bob would not be vertically down. It would not be perpendicular to the ground until you got to either this point on the equator, the South Pole, this point on the equator, or the North Pole. At any given latitude between these points, the plumb bob can never point vertically down. Okay, you've probably guessed what I'm going to do next, and that is to put the exact dimensions that we're given for the Earth into AutoCAD as well. So this dimension here, which is across the equator, is 12,756, and the polar diameter is 12,714. So let's just verify that. 12,756 and 12,714. So in AutoCAD it's very, very easy to draw this this ellipse to the exact dimensions. So I just start the ellipse command, pick a center point, which is the intersection of these two lines, pick an x-axis direction, I pick the end point here, pick the y-axis direction, pick the end point here, and it just draws this perfect ellipse. Okay, so I did the same, and I drew a line 45 degrees from the center all the way up to the surface. Zoom in. Okay, and I did the same thing. I drew a line from this point here along the curve at 20 meters, so another straight line on top of a curved line. I then from that straight line drew a perpendicular line upwards by 100 meters and then finished the building off. So this building is sitting perfectly perpendicular to the actual localized piece of ground that it sat on. I then did the same and took a line from the very top corner of this 100 meter high building and drew it back to the center of this oblate spheroid earth. So they intersect in the center. They are very, 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 very close to each other. If I zoom right in, you might be able to see them sort of diverging. There they are, look. Let's zoom back out again. And by the time they get to the building on the surface, there is a distance between the plumb bob line and the building of 300 millimeters, which is about a foot. So I don't know about you, but I was always under the impression that if you drop something, it drops vertically, perfectly, but vertically, perpendicular to the surface of the earth. But our oblate spheroid earth would suggest otherwise. And I know it's only minor, it's only a little bit, but I don't know, over 100 meters, we have a 300 millimeter discrepancy. So the effect this has is that anywhere in the northern hemisphere, a plumb bob would be drawn to the north to try and align itself with the centre of the earth. Then as you travelled to the equator, it would align itself perpendicularly exactly, and then as you travelled south, the plumb bob would try and align itself southward to align itself with the centre of the earth. So we all intuitively know that this doesn't happen. We've used spirit levels and plumb bobs. We know how accurate they are. Everything falls vertically, perpendicular to the surface of the earth. So by what mechanism is the earth using to correct this small error? Since whatever falls to the earth, perpendicular to the earth, is not going to intersect with the centre of the earth. It just can't. On a spheroid, on an oblate spheroid, anything on earth, so long as it's not at the equators or the poles, cannot intersect the centre of the earth and remain perpendicular to the earth. Just impossible. So what is happening is the gravitational pull deflecting as soon as it gets to the surface of the earth, or is it a curved line? Is the gravity curving in towards the centre? I don't know. I did some research, some limited research into this. I did find a phenomenon known as vertical deflection, but this is talking about in the vicinity of large geological objects such as mountains or supposed pockets of denser material towards the inner earth, affecting the way that plumb bobs behave in some areas. But obviously that's localized to areas that have them specific conditions. If we're talking about a generally flat open area, these effects do not occur. So by what means is the earth using to find its center point? So from here on in, it all goes a bit pear-shaped, quite literally, because we are told that the earth is not an oblate spheroid after all. It is actually slightly pear-shaped. Now these two pictures here are massively exaggerated. Even this one here is exaggerated, but it talks about a flattening in the northern hemisphere around this edge and bulging in the southern hemisphere, so around here. and that's sort of analogous to a pear, just less exaggerated. So I'm not sure about you, but can anybody point to the centre of this shape? Where exactly is the geometric centre of a pear-shaped object? Well, the answer is there isn't one. There isn't a geometric centre. It could be anywhere. It's the centre of this point could be or will be the different to the centre at this point. In fact, anywhere along the surface of this pear-shaped object, the centre is at a different point. At least with the oblate spheroid, no matter how pronounced, like this one for instance, we can still find a centre point just here. So it looks like nobody can really agree or settle on the exact pear-shapedness of the Earth. I've looked to see if I could find any numbers so I can actually draw it to see what's happening in the northern and the southern hemisphere, but it doesn't seem like even science agrees on what the exact shape is. But needless to say, they all agree that it is pear-shaped, and that if it was, this whole problem would become even weirder. So, just food for thought, folks. I hope you enjoyed the video. More to come soon.